All righty, so this is going to be your review for your Bio 1111 midterm exam. It is going to cover your chapters 1 through 8. It is 85 questions of multiple choice, 15 questions of matching, 100 questions total, 2 points apiece. That is 200 points. So there is an extra credit component. It is basically giving you 2 cells, an animal cell and a plant cell that are empty. And those cells is just fill in the blank. There's no word bank. These are things that you're just going to have to know. It is identifying your organelles. If you spell your organelles decent enough, and I know what it is that you're trying to say, credit is judgmentally given. If it is so off the cuff, I can't give you credit for something that doesn't look like it. So just kind of heads up. There's 16 blanks, half a point apiece, possible extra credit, total of 8 points total. All right, so let's get started. As far as from chapter 1, you want to make sure from your chapter 1 that you are understanding science, that you are understanding the scientific method, that you understand the levels of biological organization. So basically from the earth all the way down, all the way specific to the atoms. And so that was something that was presented in your chapter 1. Also from your chapter 1, like I said, scientific method, we talked about that. Make sure that you have natural selection, evolution, those understandings, and there are very specific slides in your chapter 1 PowerPoints that are almost verbatim of what these exam questions ask you. So definitely referring to your chapter 1 slides. So I may be coming back to chapter 1, so go ahead and put a pin in it for a moment. I'm going to go ahead and slide into your chapter 2. Your chapter 2 is chemicals, atoms, molecules. And so with that, you really need to know the ins and outs of all of your chapter 2. And so as I give you a list, just know that it doesn't stop here. Really understanding your atom at that basic atomic function. You should be proficient on how to use your periodic table, all of the trends of the periodic table. For example, what it means to be in column 1 versus column 2, all the way through column 8. In column 8, that is going to be your noble gases. And that is because the valence electrons are full. So understanding what it means to be in column 1 and how that will give away an electron because there's only one electron in its valence. When it gives away an electron, it gets a positive charge, and what that means for column 2 and so forth. For example, on the other side, column 7 is going to accept an electron to fill its valence. So that is it's going to end up with an extra electron, thereby giving it a 1- charge. And so understanding your rows, for example, like your first row only has 1 shell. Your second row has 2 shells. Your third row has 3 shells. Okay, so understanding what that looks like. You will not be required to draw an electron configuration diagram on any of my exams, but you should be able to look at an electron configuration diagram and understand what that means in terms of the electrons, protons, and what atom you're looking at. Okay, so from there, you should really understand all the vocabulary that goes with it. Protons, neutrons, electrons, how to calculate how many electrons using the atomic mass. What is the atomic mass / atomic number? What basically all the vocabulary that goes with that. How from there bonds can be made. You have three main bonds that we talked about. We talked about ionic bonds, covalent bonds, and we talked about several levels of covalent bonds. You have single covalent bond, double covalent bond, triple covalent bond. We also introduced in chapter 2 the unequal sharing of your electrons in a covalent bond. And we call that a polar covalent bond, and gave a perfect example of water and the polarity of water. And then to oppose that, you have the non-polar covalent bond, which is essentially the equal sharing, pretty much equal, of electrons around a molecule. And so understanding that. So that takes you into the third type of bonds, because I mentioned ionic, covalent, and the third type of main bond is going to be your hydrogen bond. And the hydrogen bond is going to be that attraction between the positively charged or partially positively charged, depending, of one atom or molecule, their hydrogen, towards the other atom or molecule negative charge. And so the hydrogen bond is that attraction. It is considered the weakest bond, while the covalent bond is the strongest bond. So that information has now taken you into chapter 3 when you talk about water. So your chapter 3 water chapter, the biggest thing that I can tell you is water is awesome, and it is because water is polar, and water is polar because of its unequal sharing of electrons and of the polar covalent bonds. So with that, the polarity of water facilitates those hydrogen bonds between water molecules and between other polar molecules. So that is literally the whole premise of the water chapter. And that beauty of that water chapter takes you into the 4 main properties of water. So in your chapter 3, there is one slide that says those 4 main properties of water. And those 4 main properties literally lay out the rest of the chapter. And so you definitely want to be studying from those chapter 3 slides. The first main property of water is going to be that water has I'm having a brain fart trying to just get this going. Here we go. The cohesive nature of water, which is water sticking to each other via those hydrogen bonds, and the adhesive nature of water, which is water sticking to other polar molecules. And it also talks about surface tension, which is an extreme circumstance of cohesion. That's your first property of water. You should be in all of these properties. I'm giving you the quick overview. You should be very comfortable with all of them. The second property of water is going to be water's ability to basically moderate temperature, okay? Specific heat. So what that means is water only has small changes in its own temperature. It can moderate its temperature. If you put water in an extremely hot place, the water can take in lots and lots and lots of energy with only small changes in its own temperature. And so this is also on the slides. So with that, it takes 1 calorie of energy to change 1 gram of water by 1 degrees Celsius. 111. Okay. With that, that is going from 1 degree all the way to 99, 100 degrees. Once you cross in, that's what we're talking about, liquid water. Once you cross over from 99 to 100, and your liquid water is absorbing energy to become gaseous water, your hydrogen bonds are strained. Those hydrogen bonds to this point have been absorbing energy, heat energy. In order to break those bonds, you have to input large amounts of energy to break those hydrogen bonds. I will provide you with a graph so you can see how much. I won't test you on how much energy. I'm just letting you know it's a lot, a lot, a lot. It breaks those hydrogen bonds, thereby changing liquid water into gaseous water. And in order to condense, you have to remove energy. To change gaseous water back into liquid, you remove the energy. To freeze water, you remove energy. And then that will take liquid water into solid water, which is ice. In order to melt ice, you put in energy, i.e. heat. So this, what I've been describing, is specific heat that water can withstand change in its own temperature and take in lots and lots of energy with only small changes in its own temperature. So that was the second property of water. The third property of water is going to be that solid water is going to float on liquid water. Okay, so the formation of ice. And that has to do with the water molecules being spread apart in solid water and the hydrogen bonds becoming in a fixed position. I'm going to go ahead and refer you to your slides. It's pretty simple, straight to the point. The fourth property of water that you will be tested on is going to be that water is an awesome solvent. It's an amazing solvent. And that has to do because water is polar and water can dissolve other polar molecules. And that is what makes water the solvent of life. And us able to live with water because our body dissolves all of the large biological molecules in the water-based medium of our body. You will not be tested in your in your midterm on molarity. On your lab practical, you will be tested on molarity. Okay, so back to your midterm exam. When it comes to water being an awesome solvent, you need to basically understand everything else that goes with that, defining solute, solvent, and solution. These are on your slides. Going into pH, this is also with water being an awesome solvent. Different solutions that water makes have different pHs. You should be familiar with what pH is, how to apply it. I will not make you calculate a pH, okay? You should be able to look at your pH table and understand alkaline basic versus acidic. And basically, no pun intended, alkaline basic is going to be your 14. Acidic is going to be your 0/1 down there. Neutral is going to be 7. You should understand how that pH table goes in a logarithmic change of 10 times. So as you go from 7 to 8, you became 10 times more basic. As you go from 7 to 9, 7 to 8 is 10, 8 to 9 is 10. So 10 times 10 is 100. As you go from 7 to 9, you became 100 times more basic. So you got to understand that. Also understanding what does that mean in terms of hydrogens versus hydroxides. Because your hydrogens, if you have a solution that has more hydrogens, you're looking at an acidic solution. And acidic solutions are going to give off hydrogens because they have too many. And a basic solution has more hydroxides. And so a hydroxide is going to accept hydrogens because it doesn't have enough hydrogens. And the whole thing is you're trying to make water. Hydroxide, OH, plus hydrogen, H, makes H2O. You're trying to get neutral is the whole thing. So make sure you understand all of that premise of that water property in chapter 3. All righty. I haven't even looked at my page yet. Chapter 4. In your chapter 4, this is your carbon chapter. Nice thing about chapter 4 It builds upon everything you've already learned. You should definitely be familiar with carbon and how carbon makes its molecules, the covalently bonding of it, what it takes to fill its valence. I'll just be honest with you. I mean, you just really need to be familiar with carbon and its abilities. So really, it's an easy chapter. If you feel comfortable with chapter 2, because you should have gotten comfortable with your carbon and your valence electrons and your bonding, covalent bonding in chapter 2. So one thing that is new to chapter 4 that wasn't introduced before is isomers. Isomers, when you have your two molecules that have the same molecular formula, but they have a different electron configuration. So that's something that is different. At the end of your chapter 4, there's a very specific set of tables that talks about your functional groups. Absolutely, you have to know your functional groups. You have to be able to recognize the molecule. You have to be able to recognize its function and how it changes. So like, for example, OH. OH is a functional group. It is a hydroxyl. And when you put a hydroxyl on another molecule, that molecule becomes an alcohol and it changes its function. So if you were to put an OH on methane, methane is nonpolar. If you put a hydroxyl on a methane, because of the O in the OH, you changed its polarity. So methane by itself is nonpolar, doesn't mix with water. But when you put an OH on it, it became methanol, an alcohol, and it is now soluble in water. So each one of the sections on those tables says these things. And you should be able to identify them and know the functional change of them. Okay, so going into your chapter 5. Chapter 5 is all of your large biological molecules. The first 3 large biological molecules, you will find this in the chart that I provided you in addition to in your chapters. It's going to be your carbohydrates, your proteins, and your nucleic acids. Those are the 3 main macromolecules. They're macromolecules because they go in repeating units. And then the 4th large biological molecule that does not fit on the table because it does not go in repeating units, so it is not a macromolecule, is going to be lipids. So I'll repeat again, your 4 large biological molecules: carbohydrates, proteins, nucleic acids. And the other one that doesn't fit on the table is lipids. All righty. My table is 100% complete in everything you should know. So monomers, dimers, polymers, functions. All the example molecules that you should know, and you should be able to identify example molecules. Like, for example, you should be able to identify what a glucose molecule looks like just by looking at a stick figure of a molecule. For your final, you'll have to be even more in depth with all of them, but I would be able, if for this midterm, you should be able to look at a molecule and be like, oh, that's a carbohydrate, or oh, that's a protein, right? What gives a protein away? It has a hydroxyl group. I'm sorry, my bad. What gives a protein away is it has an amine group, an NH3, and it has a carboxyl group. Okay, so guess what that takes you to? Your functional groups and being able to identify them. So that is information from chapter 4 that is going to cross over into chapter 5. Yeah, no, and I gave you the very basics of those molecules, and you should be proficient in all of them. The one thing that is not on the table that you should know are your reactions that make them and break them. And that's going to be your dehydration reaction, which removes the water and facilitates the bond. So thereby a dehydration reaction is going to take small monomers or polymers and make larger ones. A hydrolysis reaction is going to bring water in, hydrolysis. And so the water comes into the reaction, cuts large molecules into smaller ones. Alrighty. So I've gotten you through chapter 5. I'm going to go ahead and pick up my exam now and look at it. And make sure that I'm pretty sure I covered everything. I had promised you that I would circle back into some chapter 1. See if there's anything else I need to add onto chapter 1. You can go ahead and on your chapter 1, where I talked about evolution and natural selection, make sure you understand Darwin. And there's a very specific slide that talks about Darwin's mechanism of descent with modification. So I would say Darwin, descent with modification, find the slide. The question's almost verbatim. One thing I did not mention, oh, I haven't gotten there yet, my bad. That's in chapter 6, so we're good. Just give me 1 second as you're waiting for me on this video. Oh, okay. So in your chapter 4, there is CHNOPS, CHNOPS. You'll find this in your slides. 96% of living matter is made up of CHNO, CHNO, carbon, hydrogen, nitrogen, oxygen. If you know that 96% of living matter is made up of CHNO, you should be able to figure out what the other 4% is by looking at my possible answers. That's only hints I'm giving you. Okay. All righty, I believe we are ready to move on to your chapter 6. Your chapter 6 is going to be your cells chapter. In your cells chapter, you should know all of the organelles and their functions. When it comes to your bacterial, your prokaryotic cells, you should know the difference between prokaryotic cells versus eukaryotic cells. And even what that means, what's the difference between prokarya versus eukarya? You should be familiar with the endosymbiotic theory, endosymbiosis. So not only in this chapter studying your cells and organelle function, that'll help you in the questions. It is also going to help you on your extra credit. So you studied once, you got twice the credit. That really concludes chapter 6. Chapter 7 is about energy. Let's go ahead and first, let's talk about thermodynamics 1, thermodynamics 2. You should be familiar with thermodynamics 1 and 2. And thermodynamics 2 gets another name called entropy. And so I'll tell you thermodynamics 1, but really I'm just reading the definition in my head. All energy, energy is not created nor destroyed. It is just transformed from one form to another. Thermodynamics 2. As energy is transformed from one form into another, a loss of unusable energy is lost out to the universe, and that is entropy. I will not make you calculate entropy. It is just going to be a definition. You're welcome. All right. Understanding more in your chapter 7, the energy metabolism chapter, you need to basically understand the reactions, endothermic reaction, exothermic reaction, what it means to start out with a high state of energy and go to a lower state of energy, which is exothermic. Okay, energy is released, versus start out with a low state of energy and accumulate energy and end the reaction in a high state of energy. That's endothermic, because you put energy end to it, versus the other one, energy exits. And really just understanding reactions in general is this chapter, but this is really about the movement of energy. So last but not least, really you got to understand everything about your enzymes. Your enzymes facilitate the reaction to go faster. I made that nice and simple, but you really need to just know everything about the enzymes. You need to know the vocabulary, you need to know the mechanisms. I won't make you calculate anything on it, just understanding the vocabulary, principles, and application. Okay, don't make that harder than it is. Refer to your slides. I'm just letting you know I'm not going to make you calculate anything. So if you see any calculations in your slide, pass it up. Just look at the overall purpose of it. And that also goes with all of the different types of enzymatic processes. So refer to those last few slides in your chapter 7 or that. And then your very last slide in chapter 7 talks about a metabolic pathway and how the enzyme turns off the reactions. Make sure that you are studying, understanding that. Okay. Funny thing is, I told you that was all from chapter 7. That's chapter 8, friends. That's chapter 8. So just make a correction. Everything I just told you about energy and metabolism, that's chapter 8. I'm not going to go back and record this video. Yeah, they'll just find out in the end. Alrighty, so then, let's talk about chapter 7 then. How about chapter 7? Well, chapter 7 is all of the ways that stuff gets across the cell. Stuff gets across, when I say stuff, I'm talking about atoms and molecules. And because we want to be scientific and not say stuff, we're going to call the atoms and molecules that are trying to cross the cell the generic name of solutes, right? Because solutes are all of the dissolved particles in that water medium inside our cells and body. So all of the ways solutes get across the cell, here you go. Simple diffusion, facilitated diffusion. Osmosis is specific to water, so I will define it for you. Osmosis is the movement of water from a high water concentration towards a low water concentration across a selectively permeable membrane. I'll say it again. Osmosis is the movement of water from a high water concentration towards a low water concentration across a selectively permeable membrane. Okay. Those three things I mentioned, diffusion, facilitated diffusion, and osmosis, those are all passive. Means energy is not needed. Now, energy will be needed in the next. Active transport, going from a low concentration towards a high concentration. Exocytosis. Endocytosis, and the three different types of endocytosis: phagocytosis, pinocytosis, and receptor-mediated endocytosis. Then we also have the hydrogen pump that facilitates the hydrogen proton pump transport. All of this is in your slides. This is nothing new. This is stuff that you've already looked at, done, and taken your quizzes on. So those were all active. And that sums up chapter 7. So as much as it seems like I didn't say much about that, it's because you got to know it all. You got to know all of those pieces. this is not a vocabulary test. Yes, it could have some vocabulary questions, but consider that 15% of the test and 85% of the test is application. So you have to be able to know and apply. Taking a nice quick peek at my exams, make sure I didn't leave off any type of random stuff. I did leave off something of in your chapter 7 that we can talk about. It might have been chapter 6. I don't know. I think it was chapter 7. It has to do with hypertonic, hypotonic, and isotonic, and what defines tonicity. So I'll let you go ahead and look that up, watch the beautiful videos provided. If there is a chapter 7 video missing, I will make sure that it gets a replacement. And if there isn't for you guys in my future classes, don't worry about it. Okay. Make sure functional groups, there we go. All right. That concludes everything.